Oh, hello again. Yes, I'm still trying to find my way out of the escape room at Mathlock Mansion. I need to use my math skills to solve the puzzles in this room and get out. Maybe you can help me like last time? So far, we've found a few puzzle pieces, but there's still a long way to go before I can make my escape. So I found our next puzzle on the desk here. It doesn't have any directions this time, just these equations and these answer spots. Oh, I know. I bet we have to solve these equations and match them up with their solutions. Well, we're equation solving experts, so that should be no problem. Let's start with the top one. What do you notice? There are two n terms in this equation. There's the 3n on the left of the equal sign, but also the 5n on the right. I know that to solve an equation, I need to isolate the variable, but how can I get n by itself if it's in two different places in the equation? This would be so much easier if we could just combine them into one n term. Wait, can we do that somehow? An equation is made up of two equal expressions. It's critical that when we're working with equations, we keep both sides equivalent and balanced. Right now, there are 3 n's on the left side and 5 n's on the right side. If I just bring them all together on one side or the other, then they won't be equal anymore. So, how can we combine the two n terms while still keeping the equation equal? I can do anything I want to an equation as long as I do the same thing to both sides. What could I do to both sides of this equation to turn my two n terms into one n term? Oh, what if I subtract 3n from both sides? Taking 3n away from the left and taking 3n away from the right will keep this balanced, no matter what n is worth. What does this equation look like after subtracting 3n from both sides? 3n minus 3n makes 0, leaving just 7 on the left. On the right, 5n minus 3n makes 2n, leaving 2n plus 15. Hey, now this looks like the equations we're used to solving. Pause the video here and finish solving for n on your own now. With a single n term, now we can see that n is first being multiplied by 2, and then 15 is being added to it. We can undo these in the reverse order of operations to isolate n. First, we'll subtract 15 from both sides, giving us negative 8 equals 2n. Then I can divide both sides by 2 to get negative 4 equals n. Oh, I bet that means I should connect this equation to the negative 4. 1 down, 2 to go. This equation seemed tricky at first because there are n terms on both sides of the equal sign. Just like for constant terms, we can use inverse operations to cancel one of the variable terms. Once there is a single variable term left, then we can work to isolate the variable like normal. Let's practice with this method on 2 example problems. Our next problem is 10 plus x equals 5x minus 14, and it has an x term on both sides of the equation. The first thing that we need to do here is eliminate one of these x terms. Pause the video here and use an inverse operation on both sides of the equation to cancel one of the x terms. There are actually 2 equally valid ways to approach this. I'll walk you through both of them. One option is to eliminate x on the left by subtracting x from both sides, making 10 equals 4x minus 14. Now there's only one x term left on the right side of the equation. The other option would be to cancel 5x instead, which we could do by subtracting 5x on both sides, creating 10 minus 4x equals negative 14. Here, there's only one x term remaining on the left side of the equation. Both of these are totally correct. Since we can do anything we want to an equation as long as we do the same thing on both sides, there are often many ways to approach solving the same equation. No matter which method you used or you prefer, pause the video again here and isolate x to finish solving. If you subtracted x from both sides, and we're working with this equation, then you will have seen that x is being multiplied by 4 and then subtracted by 14. To isolate it, we would have added 14 to both sides and then divided both sides by 4 to get that 6 equals x. If you subtracted 5x from both sides and were working with this equation, then you will have seen that x is being multiplied by negative 4 and then being added by positive 10. To isolate it, we would have subtracted 10 from both sides and then divided both sides by negative 4 to get, x equals 6. I'll connect this second equation to 6, and now we have just one more problem to go. Wow, so no matter which approach we take, it still brings us to the same solution. I think you're ready to try this on your own. Pause the video here and solve this equation independently now. We have two c terms and I need to cancel one of them. I can either subtract 8c from both sides, making negative 5 equals negative 1c minus 12. Or I can subtract 7c from both sides, making c minus 5 equals negative 12. If you got stuck trying to cancel one of the c terms, now is a great time to pause the video again and try to finish this on your own. No matter which approach you took, you can finish solving to get the same solution. C is negative 7. Let's just connect this last equation to negative 7. Oh, it unlocked the desk drawer. There are some more pictures in here. I'm still not sure what to do with them, but hopefully they'll eventually lead me out of here. Today, we worked with equations that have variables on both sides of the equal sign. We learned that we can eliminate a variable term by adding or subtracting it from both sides of the equation. Then, once there's just one instance of the variable term left, we can isolate it like normal using inverse operations in the reverse order of operations. Once you're finished up with your guided notes, move on to the day 1 practice levels. And remember, math is everywhere. Keep exploring, and let me know if you find the exit. Hey, hey.